Dear students, in our previous class, we have discussed about applications of arrays, advantages of arrays, and disadvantages of arrays. But in today's class, we are going to discuss a little different topic under data structures, that is stacks. What actually the stack means and which are the operations can be performed under stacks. All these things today we are going to discuss. Now we shall look what is meant by a stack. For example, if you are creating a pile of books, that means in a table you will arrange a books one above the other in a pile. So what will happen in that pile? If you want to take any book from that pile, at the time you have to remove the book from the top itself. If you try to remove the book from middle or from bottom, then what will happen? The pile or the stack of that book will get fall down. These things will happen under the stack. And if you take a pile of plates which are arranged one above the others, if you want to take a plate from middle or from bottom, so at that time you should take only the top plate at first. It means the plate which is kept at last should be taken out first. Same way in the pile of books also, the book which is kept at last on the pile, that should be removed from the pile at first. So come, we shall see what actually the stack means and how it will work. Stack. Stacks. A stack is an ordered collection of items where the insertion and deletion of items takes place at the same end. For example, now we will take one stack. Okay, stack will be like this. Okay, think that now this stack is called as an empty stack because it does not contain anything inside it. So now we are going to put something. Think we are putting books inside that. 0, 1, 2, 3, 4, 5. Okay, we have put some items. How many items? 6 items totally we have put inside the stack. Here, stack, what it defines? A stack is an ordered collection of items. Items are collected orderly in a stack. Okay, stack can be called as the ordered collection of items. Okay, then where the insertion and deletion of items takes place at the same end. Insertion and deletion of items takes place at the same end. Okay, look here. Here stack is closed, but one side it is open. Okay, in bottom it is closed, but in the top it is open. This means, okay, in stack for this thing, because only one end of the stack is open, because of this thing here, inserting a new item took place from the same end. Okay, then and deletion of items take place at the same end. If you want to remove any item, you have to do from here itself. So this is actually called as a stack. It's an ordered collection of items where inserting an item, okay, and deletion of an item takes place at the same end. So this is called as a stack. Now we shall see. This is having two ends. One end is closed end, the other end is open end. What do we call these two ends as? Okay. The end, okay, the end where items are added or removed, that end is called, that end is called as top. See, this end we can call it as top because the item can be inserted here only and item can be removed here itself, top. And the end, okay, and the end opposite to top, the end opposite to top is called as, okay, I'll write top in capital so that you can understand, okay, this top only here, okay, opposite to top is called as base. One is top, the other one is base. This can be called as a base, okay, because it is closed end. Here nothing can be inserted and nothing can be removed. Okay. Stack is an ordered collection of items where the insertion and deletion of items takes place at the same end. The end where the items are inserted or added or removed. Okay. That end is called as a top, and the end which is opposite to top. Okay. This is top end and this is the opposite end. The end which is opposite to the top end is called as a base. Okay. Stack can be defined as, in other words, it can be defined like this: ordered collection of items where the insertion of, okay, in other words, it can be written as, it can be defined as insertion of new item, and the removal of, and the removal of existing item, existing item takes place, takes place at same end. Okay, this is the most better answer. Okay, stack is an ordered collection of items where the insertion of new item, okay, if you want to insert a new item, then the removal of already existing item, okay, takes place at the same end, and the end where the items are inserted or removed, added or removed, that end is called as a top end, and the end which is opposite to this top end is called as base. Okay, hope you have understood about the definition of a stack. But here, stack will operate on one rule. Okay, come let us see what is that rule here. The most recently added item, the most recently added item is the one that is in the position to be removed at first, to be removed at first. Okay, come next point. Disordering principle is sometimes called, okay, this principle is called as LIFO, LIFO, which means last in, first out. Last in, first out. Okay, look here. The most recently added item is the one. Okay, is the one that is in the position to be removed at first. See, first we will add 0, first item. After that we will add item number 1, then item number 2, then 3, then 4, then 5. Here, the most recently added item, it means the item which is inserted at last. Okay, the item which is inserted at last. Okay, that item is in the first position, and only the last inserted item should be removed from the stack at first. Okay, because the base is closed here, so the item which is inserted first cannot be removed at first because the base has closed. Think that this door is closed. Okay, the top door is, or the top end is open, so the item which is inserted at last item which is inserted into the stack, that is the item should be removed at first, only that item. If you want to remove item from bottom or from middle, it is not possible. Okay, the item which is inserted at last should be removed at first here. Then this ordering principle is called as LIFO. That means the item which is inserted at last should be removed at first. This ordering principle sometimes called as LIFO. LIFO means last in, first out. Last in means the item which is inserted last in, and that is removed from the stack at first. That is called as last in, first out. Hope you have understood about the stack. Just like if we take a pile of books, okay, we take a pile of books like this. Okay, in this as a pile of books. Okay, which are arranged on the table. Okay, if you want to remove any book, at the time what will happen, you need to remove the book which is in the top. Okay, if you want to remove from middle or from last, then it is not possible. What will happen if you remove book from bottom? Then what will happen? The pile of books will fall down. Okay, or if you try to remove from middle, it will also not possible. Here, the book which is inserted at last should be removed at first. The same thing in the stack, the item which is inserted at last should be removed at first. So basically, stack will operate on LIFO principle, that is last in, first out. Hope you have understood about the definition of the stack. Now let us see the representation of the stack. Just like we have seen the representation of one-dimensional array, the representation of two-dimensional array, the same way now we are going to represent the stack. The representation of stack in memory. representation of stack in memory. Okay, there are two types of representation of stack in memory. First one is static representation. Static representation using arrays. And the next one is dynamic representation. Dynamic representation using linked lists. Using linked lists. Okay, two types of representing an array. The first one is static representation using arrays. The next one is dynamic representation using linked lists. One is static representation, the other one is dynamic representation. Come, we shall discuss about the static representation using linked list. Okay, how the static representation of array can be? The static representation of stack, okay, using arrays. The first one is, I read the definition, then later I will going to explain you. Stack can be represented using using one dimensional array. A block of memory which is allocated is allocated block of memory is allocated which is required to accommodate the items to the full capacity of the stack. To the full capacity of the stack. The items into the stack are stored in sequential memory locations. from the first location of the memory block. Okay, dear students, you are already familiar about the one-dimensional array. Okay, think this as array. Okay, it contains some items like A, B, C, D, E, F. Or we can take in reverse order. Okay, there is A, B, C, D, E, F. Okay, what is the condition of one-dimensional array? Okay, I have already explained you in disadvantages of array that if you want to insert a new item into an array, one-dimensional array, then at first itself you need to allocate the extra memory space for that. Okay, if you will not allocate the extra memory space for inserting new item, then at that time what will happen? Array, one-dimensional array will create a problem for you to insert a new item. Okay, same way here, stack can be represented using one-dimensional array. Okay, this is a stack. Think it is in one-dimensional array. The block of memory is allocated, which is required to accommodate the items into the full capacity of the stack. Before creating a stack, okay, we need to allocate the required memory space as same as in one-dimensional array. We have to create a required memory space to fill that stack completely with the items. Okay, and the condition in representing is that the items should be arranged in sequential memory locations, one after the other, from the first location of the memory block itself. This is the first location of memory block. Okay, from here itself we have to fill the stack completely using static representation of arrays. Okay, static representation of array states that stack can be represented in static representation of stack. Okay, using array. Static representation using arrays, it will state that a stack can be represented in one-dimensional array. According to one-dimensional array, the memory which is required to insert the item should be allocated at first. Okay, should be accommodated, should be allocated at first. Okay, where the items need to be inserted to the full of the stack. Okay, then after that, the items should be arranged in sequential memory location. That means one after the other from the first memory block itself. We should not leave any space in between the stack items. This is the rule of the stack. Now, we shall take one example. Example will be like this. There are three things we have to take. One is top. The another one is max est. Okay, and the last one is null. Okay, top means we have to think. Okay, top, don't get confused. Top means, and here base means, okay, then don't get confused. We will take some different name here. Okay, PUC. Okay, PUC, max stk and null. Think PUC as name of a stack. Name of stack or pointer. Okay. Max stk means it is called as full. Okay. Full means just not full. This is stack is full. Stack is full. Null means think this as stack is empty. Stack is full, stack is empty. If the stack is full, then we have to write it as in static memory location, that is PUC is equal to max STK. That means the stack is full. Okay, name of the stack or pointer. Stack is full. PUC max STK. It is equal to, it should be think as stack is full. If you see like this, then think that stack is empty. If the stack is empty, okay, at that time we have to represent it as, okay, if the stack is empty, then it is called as null. This is the stack name. If stack is full, okay, if it is full, then it is will be called as PUC is equal to max STK. Like this, static representation of stack, okay, using arrays. Okay, I think you have understood this. Now come to dynamic representation of stack using linked list. Dynamic representation using linked list. Linked list. Okay, this is a stack, and this is top, okay, and this is base. Okay, dynamic representation. For what we will use the dynamic representation of arrays? Though in stack representation, there is a condition that memory should be allocated at first itself to accommodate the items according to one-dimensional array rule. So, at that time, what will happen? If we want to create a new item, then what will happen? Then it will create a problem. The below item should be shifted to below memory locations. Okay, then space has to be provided to insert new item. This will create a lot of problems. So for this purpose, we will use dynamic representation of stack using linked list. Come, we shall see what this dynamic representation will explain us. Okay, the size of an array needs to be, the size of an array needs to be fixed. The size of an array needs to be fixed to store the items into the stack. If the stack is full, we cannot able to insert a new item and additional item into the array. It gives an overflow exception. exception, but in linked list we can increase the size at one time by creating a new node. A new node. So it is better to implement. So it is better to implement stack using stack data structure using linked list. Using linked list. So I will show you one thing here. Look, as I have explained, in one dimensional array, at beginning itself, the array should be of fixed size. If you want to enter a new item or insert a new item into that array, then what will happen? Okay, store the needs to store the size of an array needs to be fixed to store the items into the stack. Okay, according to arrays. If the stack is full, then we cannot able to add or insert new item into the array. For this reason, okay, if you want to add a new item, then it will leads to overflow exception. Overflow means if you go on inserting items into the stack, then what will happen? If it crosses its limit, then this is called as overflow. Okay, if the stack is full, even though you are adding items, trying to add the items into the stack, then what will happen? It will become overflow. Okay, and we cannot able to add items into the stack using arrays. So here in linked list, what will happen? The size of a stack or size of an size of a stack can be increased in linked list. How? By creating a new node. Okay, by creating a new node can be created. So it is better to represent the stacks using dynamic linked list. Now I will show you how a new node can be created. Okay, if you are okay with this explanation, now I will show you creation of a node by using linked list. See, we will take it as a starting point. Start. Okay. See, these are called as nodes. Okay, these are called as nodes. Start from here. Every node is having its two divisions. Okay. The first node will always be connected to its next node. Okay, think like this linked list can be created. Okay, take some numbers, any number, 50, 25, 20. See here it is null. Okay, this is linked list, and this each thing can be called as a node. These are called as nodes. Okay, here linked list, we can increase the size at runtime by creating a new node. New node means this is a size of a stack. If you want to add more item to the stack, then at that time we have to create a new node here. Again, new node can be created. Okay, then it is inserted into the stack, and always the last will be the null by creating a new node. Okay, here new node is created and the item number 15 is inserted to that stack. So here it will not create any problem because end is open. If you want more items, again you can create one more node here. Okay, 10. Then null. Then you can able to add new node. How many nodes you want? You can by adding the nodes one after the other, you can able to increase the size of the stack using linked list. This is regarding dynamic representation of stack using linked list. This is the difference between the static representation of stack, the static representation of stack using arrays, and the dynamic representation of stack using linked lists. Hope you have understood all these things. And in our next class, we shall discuss about how can we insert a new item into the stack, or how can we delete an existing item from the stack, and also what are the operations performed, just like in one dimensional array: traversing, insertion, deletion, searching, sorting, merging. The same way we can able to discuss the operations, which are the operations to be performed on stack, in our next class. Regarding this, if you have any doubts, you can ask me personally. Thank you.